Hi, I'm Miguel. Welcome to a new episode of TechBites. You might have already noticed there's something different. Yes, the background music. This piece of music may not be as impressive as what Duke Ellington wrote, but it is real jazz. Soft piano, drums, and saxophone sounds are properly arranged and combined with the right rhythm, and it is generated by Google MusicLM. All we have to do is enter 2 words as a prompt: relaxing jazz. Now moving on with the video. In previous TechBites, we have covered several topics about Google's investment in AI, such as the large language model Palm 2 and the next generation search engine, AI Snapshot. They are rather focusing on only natural languages. However, we know that Google is ambitious in making a large model that has multi-modal abilities, which means that it could process not only languages but also visuals and sounds. MusicLM, our main character today, is going to be an important gear of the almighty machine Google creates. MusicLM, LM for language model, is able to generate pieces of music with text inputs, or in short words, text to music. As compared to the usual text-to-text models, this task is way more difficult. Think of a piece of music that you like. It must have a good structure, meaning there are some repeating patterns with progressive storytelling. There is melody and harmony that needs to be tuned. Music is too abstract to be described, which leads to similar difficulties in the AI field. So how has Google managed to achieve this? There are 3 components in the model, and they work under a hierarchy. First one, W2V BERT. You might have heard of BERT, an improved structure based on transformer design for LLMs. You can simply consider this part as a BERT model for audios. It can take care of the semantic information and the models for long-term structure of the music. Then we have SoundStream. It is initially designed for compressing the music files, and it takes care of the audio information. Then the core part, Mulan, which takes in both the text and audio information and tries to build the connection between these two during training. So it is the joint training that gives it the ability to generate music from text. The whole structure is like specialists in languages and music collaborating to produce the music for us. The actual model architecture is more complicated than this high-level explanation, but the complexity goes with the great potential of it. MusicLM is really versatile in terms of its input and output. First of all, the length of both inputs and outputs could vary in a wide range. We can simply enter 2 words as relaxing jazz and expect it to generate a full 5 minutes of music. Or we can enter a whole paragraph specifying our needs and let it generate it a 30-second piece. It could still precisely meet the requirements. People have different purposes in generating the music. Sometimes we just want some inspirations in a certain genre, in which we can try short text inputs and longer music outputs. In the opposite, a concrete description would make the output more fixed. More than that, MusicLM has the function called story mode. If we add timestamps in the text prompt, we can actually control each part of the music. MusicLM will help in the transition between each part. The current music generating models may not be good at creating music that is complete with emotion and logic. But when we have our own story to tell by music, this function would allow people who don't have the professional skills to express themselves. Other than adding timestamp, it is also possible to specify the musical instruments, the styles, and even the experience level. The model can generate correctly in all the tasks. As long as we have some knowledge in the music domain, the model can identify the needs and achieve it precisely. Just like the magical ability in large language models, MusicLM has vast knowledge and is able to link it with audio sequences. The text input not only can be music related, but also be describing images. Although it is impossible to directly put an image onto the model, we can consider it as an exploration of large models developing connections between image and audio. Some people are worried that text-to-audio models are going to destroy the music industry, but under the principle that AI is a tool, not replacing humans, models like MusicLM are probably going to help us in creating music more efficiently. In the music industry, musicians and singers are always hungry in finding creative ideas. Using MusicLM, they possibly could try more combinations, make their concept to be realized much quicker than the old ways. With some fine-tuning to the model with their own music data, the style could even be more consistent. The influences may be bigger for other industries that don't pursue high artistic value in the music. For example, the game industry. You might have heard of the news when Stable Diffusion came out and many game art designers have lost their jobs. It is quite similar in the music domain. Now we have MusicLM that can generate music pieces based on text descriptions of the image. Game developers can simply generate the music by entering the theme and scenes of the game. Individual game developers would be so glad to use this tool, as many of them know little about making music and have to buy outsourcing music sets for the game. For other fields like mental therapy, education, or even TikTok video content providers, generated music is a really good option for saving costs while still achieving satisfying quality. Among the music generating models, MusicLM is not the only one, but seems to be the most powerful. MuBert is also able to generate music from the text, but the difference is that MuBert has all the music components pre-recorded, so the model is more like the combination of these pre-recorded parts, rather than generating from the very raw audio. Refusion is the same model as Stable Diffusion. The model learns from the frequency spectrum image to generate music. It is more close to MusicLM, but does not have functions like story mode, painting caption generating, adding melody embeddings, and so on. MusicLM has much more control and customization over generated music using various methods and prompts. Although MusicLM is quite competitive, it is still not drawing too much attention, and we still have to access it by joining the waitlist. Why? First of all, as we said earlier about the difficulty in developing AI in the music field, current models are only able to achieve a like in melody. More structural and subtle details are not able to be captured and generated properly by the model. Moreover, the text that we use as inputs are not able to clearly describe what is the exact need. For example, we want to generate a piece of music that describes the winter. But there is a lot to expand from the word winter. It is the Christmas with a warm campfire and family, or is it just the freezing cold? The model is not able to expand the information from merely the text we entered. Another crucial factor is legal and copyright concerns. Generating music using AI models may raise legal and ethical questions, especially in terms of copyright infringement. Music generated by AI could potentially resemble existing copyrighted works too closely. As long as we train the model using the copyright protected materials, the model would have chances to generate pieces that are partly identical to the original one, and we cannot afford the consequences once the model is published for massive use. It is uncertain where MusicLM is headed towards. Maybe it would be integrated into music production applications to help musicians to build and try prototypes. Maybe it would become part of Google's ecosystem of AI and provide the ability of connecting text and music. Maybe it would be replaced by more advanced, controllable, and efficient models. But there's one thing for sure. We build such a model in order to enable new ways of music creation process, to bring more artistic value to the world. I'm Miguel, thanks for watching and stay tuned with TechBites.